Hi guys, I wanted to talk about writing an integral as a limit of a Riemann sum today. If you take the limit of a Riemann sum, it turns out that is the definition of a definite integral. So what do we mean by that? What we mean is if we have some sort of function, all right, and let's say that function is this graph right here, f of x, okay, and I wanted to know the area under the curve from A to B. All right, so what I want to know is this area right here under the curve. All right, I can approximate it by using Riemann sums. Or what does that mean? So if I do a right-hand Riemann sum, I would come up from the right side, come over, come up from the right side, come over, come up from the right side, come over, come up from the right side, and come over. And if I get the area of all these four rectangles and add them up, then what I would get is an approximation for the area under this function between x equals a and x equals b. So one of these areas right here, this first area would be this, I'll call this x1 here, right? So this would be fx1 times, and just pretend like each of these widths are a delta x width. So it'd be f of x1 times delta x. And then if I wanted the area of the next rectangle, okay, this would be x2. So this would be plus f of x2 plus delta x, and so on. All right, and if I sum all of these f of xi times delta x's together, then what I'll get is an estimate of the area under the curve. But if I wanted the exact area under the curve, what would I do? I would get an infinite number of these rectangles, right? And if I got an infinite number of these rectangles, then what happens is that delta x would go to 0. So if I take this summation and take the limit as delta x goes to 0, okay, that would be the equivalent of taking n to infinity, right? An infinite number of these rectangles. Then what ends up happening is I get the exact area under the curve from A to B, f of x dx. So today we're going to say, okay, what if I have this formula right here, the definite integral? How do I express it? How do I change it to this limit formula right here? All right. And what I want to say before we get started is if I have the integral and I want to change it to the limit, there's only one answer. But if I'm given the limit and I want to change it back to the integral, there's a multitude of answers. That answer would not be unique, okay? So just keep that in mind. All right, let's go ahead and look at this integral. And the way we would do this first is we divide it into equal delta x's. You don't have to, but the procedure we're going to learn is you divide it into equal delta x's. And we've learned before that delta x was equal to b minus a over n, okay? And then what we're going to do is we're going to say, okay, well, let's say we have this curve, and we want the area under the curve from A to B, okay? And we're going to divide it into perfect delta x's, all right? And who knows how many rectangles there'll be here. And so if this A right here, if I call this x sub 0, and this right here is, let's see, the number of boxes we have. Let's say this is my, on the right-hand side here, this would be my first box. I'm doing right-hand Riemann sums. This would be my second box, and so on. This would be my third box, my fourth box, and these are equal widths. It doesn't look like it, but these are equal width boxes, all right? And I would go, this would be x1, right? And this would be x2, and it would go to xn, okay? However number of boxes I go to, that would be the final number over here. This would be my A, right? And this would be my B, all right? So the delta x, the width of one of these boxes is going to be delta x. So delta x is equal to b minus a over n, and then the first x here, so x1 here, okay, do you see that this x1 is actually equal to a plus delta x? And what's another way to write x2? Do you see x2 is actually a plus 2 delta x, right? And you see x3 would be equal to a plus 3 delta x. So there's a pattern here. Whatever this number is here, that's going to be the same number here. So if we call this number I, x of I is going to be equal to a plus I times delta x. And that's where this formula comes from right here. So each of your x of i's is equal to your a value plus I times delta x. And then what is f of xi? Well, f of xi is taking this function you have here. So notice that f of xi, let's say f of xi is right here, okay? It's taking the function that you have here, and everywhere there's an x, you're going to put in xi. So the function that I have here, okay, we need to be able to interpret this. The function that I have given in this problem is right here. So this is my f of x. So if f of x is equal to 2x, then what is f of xi? Well, then f of xi is going to be 2 times everywhere there's an x, I'm going to put in xi. So a plus I delta x. Okay, so let me work this problem out and things will make a little bit more sense. All right, so for this problem here, my delta x is going to be b minus a. So this is my a here and this is my b. So it's going to be 1 minus negative 2 over n. And so I don't know my n. So this is going to be equal to 3 over n. All right, then I find xi. I actually use delta x to find xi, and then I use xi to find f of xi. All right, so now I know delta x. What's my xi equal to? No, xi is equal to a, which is negative 2, plus I times delta x, which is 3 over n. And sometimes I write it like this, and sometimes I write it like this. Now be careful. My I is not I like in Algebra 2 when you learn about imaginary numbers. Okay, this I is just a counter. So sometimes in AP they'll give it another letter. A lot of times it's K and sometimes it's I. All right, then what I do is I use this xi and I find f of xi. Well, remember, f of x is 2x, okay? So f of xi is going to be equal to 2 times everywhere there's an x, I'm going to put in this I. All right, once I find my variables, what I do is I plug my variables into this limit equation right here. Is an integral of negative 2 to 1, 2x dx is equal to the limit as n goes to infinity. I'm basically just copying this formula up here, all right? From I equals 1 to n, I think that's the formula, yes. Then f of xi is this expression right here. So I'm going to put in this expression, so that'll be 2 times negative 2 plus 3i over n, and then I'll multiply it by my delta x, and my delta x is 3 over n, so I'll put 3 over n here. And that is my answer, okay? So my answer is if I wanted to express the integral of 2x dx from negative 2 to 1, this is the way that I would express it. I drew the picture like this, but this wasn't really the picture that we found, right? What we really found was if I graph this 2x function, so 2x, looks something like this. This is f of x equals 2x, and I went from negative 2, so let's say this is negative 2, to 1, and I found the area under the curve, so it's a net area, so those areas here added together, okay? And that is how, I guess this positive area up here minus this negative area triangle down here, and that is what this expression is pictorially. Let's look at this problem here. How could I rewrite this as a limit of a Riemann sum? All right, so I do the same thing I did before. I'd have 3 parts I need to find. First I find delta x, then I find x of I, then I find f of x of I, then I substitute it into my formula. The limit as n goes to infinity from I equals 1 to n of f of x I times delta x. All right, so what's my delta x? This is equal to b minus a over n. So my b here is 3, my a here is 1. Make sure you understand that the bottom number is your a and the top number is your 3, your b. So this will be 3 minus 1 over n, which is 2 over n. What's my x sub I? I memorized the formula for x sub I. It's a plus I times delta x. Okay, so that's going to be a is 1 plus I, and my delta x in this problem is 2 over n. And of course, this can also be written with the I switched around. It doesn't really matter how you write it. And then I need to find my f of xi. What does this mean? This means find my f of x, and here's my f of x right here. Okay, so I'm going to find my f of x, 5x squared minus 6. And everywhere there's an x, I'm going to plug in the xi. Now be careful. What a lot of students do is they plug in the xi and they forget the negative 6. The negative 6 is part of the f of x too, so we need to include it. So this would be 5 times 1 plus 2i over n, quantity squared, and don't forget the negative 6. Then the next thing I do is I plug into this limit formula. Okay, this limit formula says the limit as n goes to infinity of the summation I equals 1 to n. Then I put in my f of x, so that will be 5 times 1 plus 2i over n squared minus 6. Okay, this needs actually a bracket because I'm going to take that whole f of x and I'm going to multiply it by delta x. My delta x is up here. It's my 2 over n. So I will multiply everything by 2 over n. And that is how I write this definite integral as a limit of a Riemann sum. All right. What I'd like to do now is do a couple of your homework problems, and then I want to kind of show you a magic trick. Actually, I think it might be 60 on your homework. Okay, so what you're going to do is first you're going to find delta x. So remember, delta x is b minus a over n. So for this problem, it will be 4 minus 0 over n, which is 4 over n. Okay, the next thing you do is you find your x sub I. And you just memorize the formula or, go through the logic again. But it turned out x sub I is a plus I times delta x. My a in this problem is 0. So this would be 0 plus I times 4 over n. So this would just be 4i over n. All right, the next step is to find my f of xi. So to do that, the first thing I need to figure out is where my f of x is. This right here is my f of x. And everywhere there's an x, I need to plug in x sub I. All right, so this is going to look like, let's see, 12 cosine 1 plus 4i over n quantity. All right, so once I get that, then I plug it into my big formula. Okay, my big formula is the integral from 0 to 4, 12 cosine 1 plus x dx. Turns out that is equal to the limit as n goes to infinity of the summation where I equals 1 to n, and then I put f of xi here times delta x. All right, so what is my f of xi? I just copied this part right here. So this will be 12 times cosine 1 plus 4i over n. And I multiply it by delta x. And my delta x is 4 over n. I need to be careful here. I think this thing needs a bracket to be super clear about what we're multiplying the 4n with. We're multiplying the 4n with this entire f of xi. All right? That's how you do, I think it's 6 in your homework. Let's look at another problem in your homework. A solid has a rectangular base that lies in the first quadrant and is bounded by the x and y axes and the lines x equals 2 and y equals 1. Okay, so let me go ahead and draw this. So this is the x-axis. This is the y-axis. You've got a rectangular base. and it lies in this rectangle where x is equal to 2. So I'll just say this is x equals 2, and y is equal to 1. So I'll just say this is y equals 1. All right, so I've got this area right here, and I'm going to put there's a solid on top of this area. The height of the solid above any point is 1 plus 3x. Okay, so this thing it's kind of 3D-ish, right? There's something that's growing on top of this area, kind of like this is the foundation, and there's something growing on top of this foundation that makes a volume. Okay, you could think of it like a skyscraper or something. Okay, and how tall is this skyscraper at any point? Well, this thing tells me that when x is equal to 0, then this thing will be, what is that, one inch tall, or I don't know, 1 mile tall, whatever. Okay, when x is equal to 1, okay, this will be 4 inches tall. I guess we'll just talk inches. If x is equal to 2, anywhere x is equal to 2 all along here, right, this thing will be equal to 7 inches tall. So what does this figure look like? Something that, okay, this is terrible, but something that looks like I'm not very good at drawing this. Okay, but something that's slanted up. It's growing up on this. So it's shorter here, and then it grows up this way. Okay, and it's this kind of solid rectangular solid, kind of like a skyscraper with a slanted roof. That's basically what it is. Okay, where this is the foundation right here. All right. So the question is, which of the following is a Riemann sum approximation? And you have some choices on your homework. But the first thing we want to do is, well, how do you write the integral of this? Okay. Now, if you remember what we're doing here, if we want the volume of something with a known base, what is the formula of that? Remember, the volume of something with a known base is the integral of a dx, or it was the integral of a dy. Do you remember that? Where the a was the cross section of that base. All right, and so what we have to decide is, are we using x's or are we using y's? If I think about cross sections this way, do you see that each of them would be a rectangle? I mean, like this one right here, okay, would be this rectangle right here. And then the next rectangle, like this one right here, would be kind of the same rectangle, but a little taller, right? And then this one right here, if I did a cross section right here, would be kind of a rectangle, but even taller, right? And that's what we're doing. All of them are rectangles. And how high is each of these rectangles, and how wide is each of these rectangles? That the base is always 1. Okay, the base is always 1, no matter which rectangle I pull out. How high is the rectangle? Well, the rectangle height is equal to 1 plus 3x, right? That's the height. So if I wanted the area of one of these cross sections, that would just be 1 plus 3x. All right, so if I wanted the volume of this 3D figure, the volume would be equal to the area 1 plus 3x times dx, from what is my smallest x value and what is my largest x value. All right, so I set that up a little bit for you, and you guys can finish up the problem. One thing I want to point out is the way that we're doing these integrals, we're actually doing right-hand sum problems, okay? If you wanted to do a left-hand sum, then some things would change. So let me just point it out, but I just want to make sure you understand that we are actually doing a right-hand sum problem. Okay, all of these formulas. If you were to do a left-hand sum, the way you would change it is your delta x would stay the same. Your x sub I that would actually stay the same also. So that's still a plus I delta x. Your f of x, though, instead of finding f of x I, you're going to find x of fxi minus delta x, okay, just to let you know. And that will help you plug it into the formula, and your formula for a left-hand Riemann sum would still be the limit as n goes to infinity, I equals 1 to n, but now it's f of x I minus delta x times delta x. All right, so just something to keep in mind if you were doing if they specified a left-hand sum, and I haven't seen it that often. Okay, usually we use the right-hand sum method. Okay, at this point, you're ready to do your homework, so I wanted to let you guys know, those of you guys who want to stop the video, you can here. Those of you guys who would like to see some magic, I'm going to offer you some magic now. What I want to talk about is this limit right here was actually equal to the value of this integral, right? Okay, so let's think about this. That means that the value of this integral here, which I can do by hand, let me do this by hand. The value of this integral is 2x squared over 2 from negative 2 to 1. The 2's cancel out, so if I plug in a 1, I'll get 1 squared, minus if I plug in a negative 2, I'll get negative 2 squared. And what that tells me is 1 minus 4, and this is negative 3. So what that says is the net area of these areas that are under the curve, okay, really between the curve and the x-axis, that net area is negative 3. What that also means is that this limit that I found is also equal to negative 3. But how do I know that? Okay, how do I express this as negative 3? So what I wanted to do was show you how that can be done. And before we do that, we need to remember these formulas here that we hopefully saw at some point in our lives. But I can summarize them up here with you. So the first thing I want to make sure you understand, if I have the summation of I equals 1 to 5 of 1, okay, what that really means is that I have 5 blanks, 1, 2, 3, 4, 5, okay, I equals 1, then I equals 2, then I equals 3, and so on. And in every blank, I'll put a 1 in it, all right, so that'll be 1 plus 1 plus 1 plus 1 plus 1. So this is equal to 5. Okay, if I have I equals 1 to 5 of 2, okay, of course that would be 2 plus 2 plus 2 plus 2 plus 2, and that would be equal to 10, right? So it turns out if I have a summation of I equals 1 to some number n, okay, of some constant c, that's always equal to c times n. Okay, so down here this was equal to 2 times 5, and up here this is equal to 1 times 5. All right. The next thing I want to talk about is, what if I had something with a fraction? So what if I had 3 over 4 here, and I said I equals 1 to 4? Okay. Well, wouldn't that be 3/4 plus 3/4 plus 3/4 plus 3/4? And isn't that the same thing as 3? Okay. What if I said, okay, a similar problem, what if I said, what's the sum of I equals 1 to 7 of 3/7? Wouldn't that be 3/7 7 times? So wouldn't that be equal to 3? Okay, so it turns out that if I have the summation of 3 over n, and I go from I equals 1 to n, as long as these numbers match up, then my answer is just going to be the numerator, whatever it is, okay? And another way that I could write this is, since this n is actually a constant, you can actually pull that 3/4 out, or you could actually pull that 3 over n out. It's the I that's actually incrementing here, okay? The n is actually just some constant. So I could actually express this as 3 over n, the integral I equals 1 to n of 1, right? I pulled the 3n out, but over here was really 3n times 1, all right? So what that is equal to is 3n times, well, remember what we said this is equal to? This is equal to 1 times n, so this is 1 times 5. So this would be just 3 over n times n, which is equal to 3. All right? Okay, So knowing all of that, okay, what I'm going to do is I'm going to simplify, or I'm going to evaluate this expression right here. All right, I know this expression is equal to -3 because I've already calculated it. Okay, so what I'm going to do now is I'm going to try to take the limit of this summation. So this will be the limit as n goes to infinity of I equals 1 to n of, let me go ahead and multiply some things together. This will be -4 plus 6i over n times 3 over n, right? If I distribute that even more, I can get this is equal to -12 over n plus 18i over n squared, right? Now summations, they act a lot like integrals, okay? So this is actually a buy one, get one free problem. So I can distribute that summation. So this is the limit as n goes to infinity of the summation I equals 1 to n of -12 over n plus the summation I equals 1 to n of 18i over n squared. Okay, and so what I can do here, like I did before, is I can pull this -12 over n out, okay? Because remember, the n's are constant. We talked about that before. So this is the same as -12n, the summation I equals 1 to n of 1, okay, plus. And in the same way, I can pull this 18 over n squared out, because the n is really just a constant. But the I keeps going, right? The I actually is a counter, so I have to keep the I in. So this becomes the summation I equals, oops, this is 18 over n squared times the summation I equals 1 n times I, okay? Now, it turns out that the summation of 1 plus 1 plus 1 plus 1 n times is n. So this will be -12 over n times n plus 18 over n squared times. Well, it turns out actually the summation of this right here is this formula right here, okay? And what does that mean? That means, like, if I have the summation of I from I equals 1 to, say, 5, this is equal to 1 plus 2 plus 3 plus 4 plus 5. Okay, there are 5 blanks. This would be equal to 15, okay? But another way to do this without adding every single number together is to know this formula, n times n plus 1 over 2. My n is 5, so it's 5 times 5 plus 1 over 2, which is 15. Okay, so this formula works. So I'm going to write the summation of I from I equals 1 to n here. So this is really the same as n times n plus 1 over 2. All right, now remember, this is a limit problem. Right here, the n's cancel out, so what I get is a limit as n goes to infinity of -12 plus 18 divided by 2 is 9, okay? And then what I have here is n squared plus n over n squared, okay? But it's a limit problem as n goes to infinity, so since these have the same, the leading terms have the same exponents, right? The answer to the limit is the ratio of coefficients. So this actually goes to 1. So my answer is -12 plus 9, which guess what? Is -3. See? Magic. All right, so I want to do the same thing for this problem right here. This problem, I said that the integral of this was equal to this limit here, okay? And I want to verify that that really is true. All right, so let's do it by hand first. This would be equal to the antiderivative of this, which would be 5x cubed over 3 minus 6x from 1 to 3, okay? First I plug in the 3, so that would be 5 times 3 raised to the third power over 3 minus 18. Then I plug in the 1, so that's going to be 5 over 3 minus 6. Then I slap a minus sign in the middle, so this will be minus this whole quantity, okay? This 3 will cancel out with this 3, so this will be 45 minus 18 minus 5/3 plus 6, be 33 minus 5/3, and that's equal to 99 over 3 minus 5/3, which is actually 94 over 3. So what I'm going to do is I'm going to simplify this expression and see if I get 94 over 3. First, so I'll have the limit as n goes to infinity from I equals 1 to n. And let me go ahead and take this quantity to the second power. So that's 5 times 1 plus 4i over n plus 4i squared over n squared minus 6 times 2 over n. Now I distribute this 5. Okay, so what I'll get is 5 plus 20i over n plus 20i squared over n squared minus 6. I'm going to multiply all of that by 2 over n. All right, and then 5 minus 6 is actually negative 1. So what I get is negative 1 plus 20i over n plus 20i squared over n squared, quantity times 2 over n. All right, so I haven't been carrying this down, but this is still the summation from I equals 1 to n, the limit as n goes to infinity. Okay, now I'm going to distribute my 2n. So now I have negative 2 over n plus 40i over n squared plus 40i squared over n cubed. All right, and this is a summation, but remember the summation distributes, okay, like an integral sign. It's like a buy one get one free. So this will be the sum of negative 2 over n plus the sum of 40i over n squared plus the sum of 40i squared over n cubed. Okay, this will be the limit as n goes to infinity of this entire thing. Okay, remember that this negative 2 over n is just a constant. This n is some sort of constant, so it can pull out of this summation sign. This 40 over n squared can pull out, but the I cannot pull out. And this 40 over n cubed can pull out, but the I squared cannot pull out. So this is really the same as negative 2 over n summation of 1 plus 40 over n squared summation of I plus 40 over n cubed summation of I squared. Okay, but from these three formulas that we have down here, okay, we know that this is really the same as negative 2 over n times n plus 40 over n squared times n plus 1 over 2 plus 40 over n cubed times, this one's a little bit longer here, this will be the summation of I squared is n times n plus 1 times 2n plus 1 over 6. Okay, n over n cancels out here. Remember, this is still a limit problem. Okay, this turns out to be 20 right here, 40 divided by 2. Okay, that's going to be 20. This here would be n squared plus n. Okay, but if I take the limit of this right here, do you see the leading powers are both 2? So if I take n, the limit as n goes to infinity, I'll get 1 here. So this becomes negative 2 plus 20 times 1. This will be the limit as n goes to, well, I guess I'm taking the limit. So that'll be 1. Here, let me just write this. And over here, I'll have 40 divided by 6, which is really 20 divided by 3. This will be some sort of n cubed number, but it'll be 2n cubed plus something, right? So if I take the limit here, okay, I'll get 2. So this limit here will go to 1. This limit here will go to 2. This limit here will go to 2. And so this answer will be negative 2 plus 20 plus 40 over 3. All right, that's the same as 18 plus 40 over 3, which if I get a common denominator, I'll get, I think that's 54 plus 40 over 3, which turns out to be 94 over 3. And did I get the same answer as this up here? Yes, I did. All right. And so I just wanted to show you that that's magic. And thank goodness we don't have to integrate this way, okay? But if we did, we could do it. All right, good luck on your homework.